In this video, we'll go through another example of being given an area and a problem and converting it back to an x value. So we're going to start with the same example that we had in the previous video. So let me jot down again, our mean newborn baby weight is 7.5 pounds and our standard deviation is 0.6 pounds. So we're trying to figure out what would a newborn have to weigh in order to be in the top 11%. And we're going to round to the nearest tenth. And this time when I draw my normal curve, again, I don't have an x value. I don't have a weight that I'm trying to find the probability of. I am given an area of 11%. And because it's the top 11%, that's going to make me know that I'm going to shade to the right. So I'm going to shade my top 11%, which means the area of that space that's shaded would be 0.11. And I'm going to look for this z-score so that, remember, I can take my area. Find the z-score that corresponds to the area, and change that back into an x value. An x value, which would be a weight. So the first thing we're going to try to do is find our corresponding z-score. So we're going to go on to our calculator here, and we're going to do inverse norm. And we have a couple options, both that will get us the correct z-score. If we do inverse norm 0.11, let's see what that's going to get us. So we go into inverse norm. We're going to keep mu equals 0 and sigma equals 1. We're going to do our area is to be 0.11. So the calculator is giving us out a z-score of about negative 1.23. So we know that what the calculator really thinks is they really are thinking we are giving it the bottom 11%. And so that's why they gave us that negative z-score. So we can, remember, convert that. We know that this should really be a positive 1.23. Because that's where we are. We are looking at the top 11%, and we know we should be well above the mean. Remember, the other option for us to do is put in the complement. If the top 11% is really the same thing as saying the bottom 89%, right? The left hand 89%. So if we put in inverse norm 0.89, it's going to give us the 1.23. So either way we do it, it's fine. So what does this mean, really? Okay, this means that we have to be, in order to be in the top 11%, we have to be 1.23 standard deviations above the mean. Right? That's what a z-score is, the number of standard deviations we are above or below the mean. And this is saying if we want to weigh in the top 11%, we've got to be 1.23 of our standard deviations above the mean. So again, I'm underlining this because this is how you're going to get your x value. We have to be 1.23 of our standard deviations above the mean. And that's our x, right? And if you follow your formula, x would be mu plus your z-score times your standard deviation. So let's see what we get out here, and let's see how we're going to round. So again, you calculate it at the same time as me, and let's see what we get. Make sure we agree. So I have a weight of 8.238 pounds. So in this case, we want to round to the nearest tenth, it said. This is actually a good rounding example. So I'm trying to get in. So what this is really saying is the cutoff is 8.238 pounds. That's the cutoff between being in the top 11% and not being in the top 11%. So if I really want to be in the top 11%, if I keep it as 8.2, I'm technically not in the top 11% anymore because it's below this cutoff. So in this case, I'm really going to round to, I know that that 3 would make us think, oh, let's keep it 8.2. But I'm going to round up because it's more appropriate in this case to round up to 8.3 pounds if I'm trying to make it in the top 11%. So the idea is really if we're going to try to get into a top percentage, we really do always have to round up. And if we're trying to get in the bottom, we should always round down or keep it the same. Because 8.2 would be like just below, right? It wouldn't quite be in the top 11%. So hopefully that helps with a couple examples of changing areas back into z-scores, back into x values.